All right, we'll go ahead and get started with section 11.3. And this section, we're going to be solving systems using elimination. Now, sometimes this is referred to as addition, but I'm always going to call it elimination. When we're doing elimination, we always add, but just so you know, there is that alternative name for it. The way that we do this is, first step is you write everything in standard form. And standard form just means the X and the Y's are on the same side. Once you get the X's and the Y's on the same side, we multiply one or both equations by a number to get the same number and opposite signs. Then the last step is we add eliminating a variable. So I'll give you a second to copy that down, and then I'll show you a few examples. Just as a little refresher too, we did talk about three types of solutions. Now, the three types of solutions were that the two lines cross at one point, which graphing looks like this, and you get like X equals a number and Y is equal a number. You could also have parallel lines, so no solution. And when you go to solve this, you get something weird like 0 is equal to 5, or some answer that doesn't make sense. We talked about that in our last class. The third type of answer we can get is the same line, which would give us 0 is equal to 0. Those are the three different types of solutions we can get using elimination. What I'll do is maybe I'll show you 4 examples, and then we'll move on to something else. So the directions will be to solve using elimination. Let's say we had a problem where it was 6x minus y is equal to 27, and 5x plus y is equal to 28. To show that they're a system, we use this curly bracket on them. And what we're looking for is we're looking to get the same number with opposite signs. So if you look at the y's, this is positive 1y. This is negative 1y. That's exactly what we want. They're the same number, but obviously different signs. So what happens is if we add them together, you just get 11x, the y's cancel, and this is just equal to 55. Dividing by 11 gives us x is equal to 5. Pretty simple. And then we always have to find y too. So if we plug that in for x, we get 6x minus y is equal to 27. So plug in 5 for x. And then just solve. And we get y is equal to 3. So this obviously looks like there's one solution. The solution would be x is 5, y is 3. If we were to graph those two lines by either using slope-intercept form or by graphing the x and y intercepts, we would see that they would cross at 3, 5. So that would be this point, 3, 5. Sometimes elimination takes a little bit of work. So what if we had a problem where it's 3x minus 4y is equal to negative 11, and 4x plus 5y is equal to 6. Just looking at it, we don't have the same numbers, so we have to make a decision. The decision is, do you want to eliminate the x's or the y's? And what could be the smallest number that you could divide 3 and 4 into? It would be 12. We could turn the 3 into a 12 and the 4 into a 12, or we could even make the y's into 20s. So the whole idea is we want to try to make them into the same number, different signs. What I'm going to do is I'm going to convert these to 12. So I'm going to multiply this top by 4, and I'm going to multiply this one by negative 3. If we do that, we're going to have to multiply everything by 4. This would be 12x minus 16y is equal to negative 44. And this would be negative 12x minus 15y is equal to negative 18. We could have also multiplied the y's to get 20s, but sometimes you have options and you just have to make a decision. Adding these together, we get negative 31y is equal to 44 and 18 is 62. And then dividing by negative 31 gives us 2. If y is 2, we can plug it back in to get what x is. And x would be negative 1. What about something like this, where we get negative x plus 5y is equal to negative 4, and 2x minus 10y is equal to 8. Now again, we could either eliminate the x's or the y's. So I'll just eliminate the y's in this case. Looks like one is a 5, one is a 10. If I convert the 5 to a 10 by multiplying everything by 2, I get negative 2x plus 10y is equal to negative 8, and 2x minus 10y is equal to 8. We just get 0 equals 0. But when we have zeros equal to 0, if you look back to your notes, this means that we have the same line. And there's an infinite number of solutions. The way you draw infinity is just a sideways 8. Do one more of these. About 4x plus 2y is equal to 9, and 8x plus 4y is equal to 0. We could go ahead and eliminate the x's here by multiplying by -2, because that'll give us negative 8x and 8x. And if you do that, you get another one of these weird solutions where 0 is equal to -18. But we talked about that before. That's a case where there's no solution, meaning that the lines are parallel.